Good morning everybody. In the last class we have discussed the quantum mechanical postulate and how we can calculate the probability from the wave function that we have discussed, both in quantum mechanical aspect as well as statistical aspect. But most importantly, rest of the things, what is the state of the wave function, how we measure the probability, what is the condition, how to select a proper wave function to represent quantum mechanical system, I will discuss. But I would like to request you, all of you, to watch the video from starting from video to the end. Otherwise it will very difficult to understand the point, because everything I'm going to give in terms of mathematics. Okay, you just try to understand what exactly language of mathematics. Okay, today I'm going to start state of a system. I have told you that any quantum mechanical system is represented by wave function. This wave function RT. This wave function may be real, may be complex. We have to evaluate it from Schrodinger equation. Solution of Schrodinger equation represent the wave function. Okay. And importantly, D Boy suggests that important thing is that D Boy suggests that whenever particle start moving, the wave associated with it. But what type of wave associated with the particle, he cannot justify. But this answer is justified by the Schrodinger. Okay, solution of Schrodinger equation, we will get a wave, and that wave is associated with the particle as per the boundary condition. So this wave function may be real, may be complex, but the wave function does not have a physical meaning. Okay, that is why in 1927 Max Born gives the probabilistic interpretation. What do you mean by probability? Probability P R is equal to square of wave function. This is equal to psi star psi. Okay, psi star star. And this psi star means complex conjugation. Suppose wave function is this one. This wave function is this a to the power e to the power I ax. Then psi star will be a to e to the power minus I k, complex conjugation. And if you take here, this is square product. It will be a square. Okay. But in case of wave function is suppose real wave function a sin kx. This is the wave function particle in a box. Okay. Then the complex conjugation is equal to the wave function. Okay, and why we take the modulus? Because probability is always a numerical value, is a positive number, it is called 0 to 1. So that is why we take the modulus. Okay, this is the meaning of probability. Now, this is the probability density. Okay, now what is the total probability? Total probability we often write integration of PR, dr, dq bar. Now the question is that why I write dq bar? Student often write dx. Okay, dq bar means this is not power. This represents 3-dimensional. dq bar means dq bar means dx, dy, dz. Okay, this represents the volume. Similarly, that is in 3D rectangular system. Suppose square box. This is square box. Small squares cube, dx, dy, and dz. Okay. In this case, volume will be product of 3 coefficients, and you can easily understand from the coordinate system also. I will show you. And in spherical coordinate, this is equal to r square sin theta d theta d phi dr. Remember, this is the formula of volume in spherical coordinate system. So we in 12 up to in SS level we have studied volume of a sphere 4/3 pi r cube. But this is the volume of a sphere, but general formula is this. This 4/3 pi r cube is evaluated from this equation. And what is the limit of theta? Theta limit 0 to pi. You can say inch minus pi by 2 to pi by 2. Okay, no problem. And phi limit 0 to 2 pi. Okay, or you can sense minus pi to pi. Total length is twice pi. Okay. And in cylindrical system, this volume is equal to r d phi dr dz. This is in sphere. This is sphere. This is for cylinder. Suppose I am telling you, suppose one particle is inside a cylinder, then you have to use this one. If you want to find the particle inside a cylinder, then you have to use this one. Suppose the particle is confined in a three-dimensional sphere. For example, particle in hydrogen atom. 3-dimensional hydrogen atom, we always use this formula. Okay, do not use this formula. This is for rectangular system, this is spherical system, and this is cylindrical system. From where we get this? I will give the brief highlight. See, in Cartesian space, small elemental distance in Cartesian space. Okay, rectangular space, small distance is written as dx I cap, dy j cap, dz k cap. Then what is the volume? Product of this dimension with this and this. Is it okay? dx dy dz. But in case of spherical coordinate, 3D spherical system, these are is represented as dr r cap, r d theta cap, r sin theta d phi cap. This is elemental distance in spherical coordinate. Now what is the volume? Only product of this part. Is it okay? R dr into r d theta into r sin theta equal to r sin theta d theta d phi dr. Okay. And similarly, in cylindrical system, this small elemental length is represented as r d dr r cap, r dr r d phi cap, dz z cap. Okay, is it okay? R d theta, r dr r d phi dz, r d phi dr dz. Is it okay? It's a coefficient of this elemental distance in cylindrical. This is from general formula. Okay. And this 4/3, I just want to give you one example so that you can understand. So 4/3 volume of a sphere, we often write it is 4/3 pi p pi r cube. From where we get it? Always remember dv in spherical system r square sin theta d theta d phi dr. This is the general formula of volume in 3 dimensional. So what is the total volume? There will be 3 integration r square and directly put 3 integration. Okay, sin theta d theta d phi dr. Okay, so 1 integration 0 to r square dr, 1 integration 0 to pi. Okay, always remember theta value is 0 to pi. You can sense minus pi by 2 to pi by 10, so that total length is pi. Sin theta d theta and 0 to twice pi d phi. It will give 2 pi, it will give 2, and it will be how much? 4 pi into r cube by 3. So we are getting 4 by 3 pi r cube. This is how we are getting the volume of a sphere. Similarly, you can volume of a cylinder is equal to pi r square L, which is evaluated from this equation. Okay, and this is very important when if we want to understand the question of an action and net gated. So according to the problem, you have to apply the formula which one is suitable. So that's why I am giving you. Suppose from where? Suppose in hydrogen atom, this question comes in the net exam. The ground state wave function of hydrogen atom, ground state r theta phi. Ground state wave function is hydrogen atom 1 by root pi a naught 3 by 2 e to the power minus r by a naught. Okay, r naught, a naught is the Bohr's radius. So ground state wave function of hydrogen atom is this one. What is the total probability? How can you calculate? Then total probability will be z wave function square. Okay, dq bar. Now it is 3-dimensional sphere. Okay, r theta phi is there, spherical coordinate system. So you have to use psi square r square sin theta d theta d phi. Okay, dr. So this function does not contain theta and phi. So this part you can separately evaluate it except this part. So I can evaluate it psi square r square dr, because I will evaluate it after that, because I will take the square modulus of this function and then after that apply this part. Okay, this part is independent of this part is independent of wave function. Because wave function does not contain theta and phi, I can evaluate it. This will give how much? Pi sin theta d theta 0 to twice pi d phi. So it will be how much? 4 pi wave function square r square dr. So what we understand? So r square additional term is coming. So after that you put this value and evaluate the probability. This is why it is important to understand. Okay. Next dimension of wave function. What is the dimension of wave function? Because we have to understand what is the dimension of the wave function. So how will you define? Suppose total probability, this is the probability formula, psi square d cube r. This is, now we understand d cube r is volume. Okay, it may be spherical, it may be a spherical system, cylindrical system, or rectangular system, whatever it is. Total, this is the formula, this is a total probability. probability of finding, this represents probability of total probability of finding the particle, this represents this part. Probability of finding the particle within the region r and r plus dr, and integral give the total probability. So this integral means total volume. Okay, integral means total volume. So wave function into the dimension of this equal, suppose cubical system. Suppose particle is inside a 3-dimensional box. Then what equal to 1? So what will be the dimension? Psi dimension will be 1 by L 3 by 2. So what we understand, the wave function dimension is wave function 1 by L 3 by 2. Okay, in 3D. Rectangular system. This is. Suppose in two-dimensional I will consider, if it is two-dimensional, I will like dx dy equal to 1. So this will give volume, total volume. So it will be dimensional square equal to 1. So psi dimension will be 1 by L. Okay, the psi dimension will be 1 by L into d. Okay, simple. And if it is 1d, then it will be 1. So psi dimension will be half. So one dimensional, it will be 1 by L, 1d. Remember this formula. So dimension of wave function is this, according to the dimension of the particle where it is located. Okay, clear? Now well behave wave function. Well behave wave function means the wave function which are accepted in quantum mechanical system. Because mathematically large number of wave function is possible, but we cannot accept all wave function in order to describe quantum mechanical system. Okay, only specific wave function which satisfy particular mathematical condition are accepted in quantum mechanics to represent quantum mechanical system. What are the wave condition? Condition 1, the wave function, this must be finite, single value, and differentiable, square integrable. If the wave function has the same finite value and differentiable and single value and square integrable, then it will accept the wave function as a quantum mechanically acceptable wave function. Okay, what do we mean by, first of all, we will differentiable means the wave function which can be differentiable. Okay. Now this is a condition. Now I am giving an example, then you can understand. What, first of all, I will explain this single value function. Suppose this is a wave function, time independent wave function. I am writing 4 minus of modulus x. Now this is a simple poly. If we expand this, we can expand like this. Expand 4 minus x greater than 0, 4 plus x less than 0. Okay. This is the meaning of this. Meaning of this part is this. So suppose let x equal to 1. X equal to 1. Suppose you consider x equal to 1. The wave function has two values, right? When x equal to 1, you will get 3 and you will get 5. For x equal to 1. See, for a particular value of x, we are getting two value of wave function, which is not acceptable in the wave function. What do you mean by that? Suppose at a particular time, you find me in Jorhat, you find me in Guwahati. Is it possible? No, not possible. Because wave function represent a particular represent the state of a particle. If we for particular value of x, we must have a single value of x. Then it will be acceptable wave function. And another condition, wave function must vanish at the boundary. Okay. Next condition. Suppose if I consider phi equal to 4 sin pi x. See, for particular value of x equal to suppose 0, you will get a single value of x. First, one condition is satisfied. Second condition, differentiable. The wave function is differentiable. Okay, it can be square integrable. Okay, square integrable I will show you. And it satisfies all conditions. That is a quantum mechanical wave function, accepted wave function. For example, this wave function represents a particle in 1D box. Okay. But suppose if I consider e to the power x, is it quantum mechanical solution? No. It is an exponential growing solution. At infinity, x equal to infinity, wave function will be infinity. It is not vanish. Number one. It is not square integrable. Square integrable means this one. Dx less than infinity. Suppose if I take this value, suppose another wave function is x squared, one is x cubed, something like that, linear equation. If I put this value and 0 to infinity limit, then what will be the value? We are getting infinity. So according to this condition, wave function, square modulus of this wave function must be less than infinity. But this condition is not satisfied this type of wave function. That is why they are not considering acceptable. But e to the power minus alpha x, e to the power alpha x, suppose alpha greater than 0, this wave function is not accepted wave function in quantum mechanics. But if I take e to the power alpha x, alpha less than 0, then this wave function is considered as accepted wave. Because alpha is negative, then wave function varies at the boundary. This is the condition how to select the particular wave function are well behaved or not. Okay. Then superposition principle. I have the superposition principle. Superposition. This is a basic thing. I want to teach you, because if you start quantum mechanics from basic, then you can easily understand. Any problem you can easily solve it. No, without any hesitation. Okay. That's why want to give the basic highlight. After that, I will move to the numerical problem. So superposition principle is that if the wave function we cannot write a single particular we cannot write like this a phi 1, suppose a1 phi 1, we cannot write this. Yesterday I told you. Why? Because you cannot predict exact location of the wave function, and it may be in state A, it may be state B. Suppose 3 location. This is the wave function of a particle A particle. It may stay in this state, 1 state, it may stay 2 state, it may stay 3 state. Okay, this state is represented by phi 1, this is represented by phi 2, this is represented by phi 3. What does it mean? Suppose A is a particle, quantum mechanical particle, is represented by wave function phi. Okay, it has 3 locations. Okay, this wave function may stay this state, it may stay also this state, it may stay also third state. Okay, in that case you have to represent the wave function is like that: a1 phi 1, okay, a2 phi 2 plus a3 phi 3. Okay, this a1, a2, a3 will characterize the particular state. Okay, it may be energy eigenvalue. Understood? So this is known superposition principle. And next condition, if this wave function satisfies Schrodinger equation second order linear differential equation. If this wave function satisfies Schrodinger linear differential equation, then this also must satisfy the Schrodinger linear differential equation. Okay, clear? This is known as a superposition principle. Now, suppose this is the particle A, wave function is phi, it has three locations, this is 1, this is, it may stay, this is state 2, it may stay 3. This represents psi 3, this represents state psi 1, 2, this represents psi 1. Okay? Now question is that, how can I measure the probability of finding this system at particular state 2? Yesterday I have told you can easily find out. This is nothing, just Pn. Suppose psi 2 want to measure, this is the formula, only this step, A2 square. This is the probability. Okay? This is a superposition principle. Third is operator and observable and operator. See, no need to remember, memorize all this formula. You just memorize the original equation. Okay, this operator means which P is already I have given minus I is cos del x in 1D, 3D it is I is cos del. Energy, similarly energy is operator I is cos del T. Okay, del D. Now how can you find out Hamiltonian operator? Hamiltonian operator is easy. Yesterday I have shown you P square by twice M plus V. Just put this one minus H cos square by twice M del square plus V. This is operator representation of Hamiltonian operator. Okay. So it is easy. Now how can I evaluate the angular momentum? Angular L equal to R cos P. So one thing is C x I cap plus y j cap plus z k cap into Px I cap Py j cap Pz k cap. This is what, and you can find out the determinant I j k x y z Px Py Pz, and left side equal to Lxi Lyj Lz. This angular momentum operator is very essential. Once we do the commutator analysis, okay, we will teach you later. So this is a long procedure and time consuming also, because we don't have so much of time in exam to remember, to evaluate the Lx, Ly, Lz. So I will give the short tips how to remember. So you just remember this one, x, y, z. So unit vector in rectangular coordinate system I, j, k, like that. So whenever we write Lx, so x next term will be y. Okay, next term must be what? P. First term is coordinate, one is momentum. Always remember. First term is y, x, then y, and P. Here x is there already. So there must not be x term. Okay, only remaining term y and z. So it will be z. So x, y, z. X, y, z. Okay, and next term will be reverse of this term. Z will come here, T, y come down. Similarly, y term, whenever I consider y, next term is z. Next term is z. If z is there, then it will be what? X is left out. Z is left out. Only remaining term is x. So it will be x. Next term will be x, p, z. Reverse of this. Similarly, Lz equal to z, x equal to x. So remaining term is p, y. So next term will be y, p, x. This is how you can remember. And after that you can put this value. Put this value equal to p equal to what? I is cos del x for x. Similarly, Py is there, Pz is there. If you just plot, you will get I is cos y d by dz minus z d by dy. Okay, this one minus I is cos z d by dx minus x d by dz. Similarly, minus I is cos x d by dy minus y d by dz. This is how it's very easy to remember. This angular momentum operator is very important. You always remember and using easy text. Okay, now I am giving the example. Question number 1. Consider a system. If a system is found at t equal to 0, is represented as psi x0. If a system is found in A1, I1, A2, I2, dot, and what is the value of psi at t equal to ts? So what is the value? Yesterday I told you this is nothing. You remember that yesterday Schrodinger solution. What is the solution of wave function? This is independent of time but static solution. Okay, we need dynamic solution. Okay, dynamic solution is equal to what? Sum of an phi n equal to minus I e n t by this is. So this part is already given. This is static part. This part is you have to add. Okay, this part if you want to add, you have to write x t or t dash. You can add a1 phi 1 into e to the power r e1 t by a square. Okay, next one a2 phi 2 e I e 2 t by a square. Dot a n phi n e to the power minus I e n t by a square. Okay, and simply you can write sum a n phi n e to the power minus I e n t by a square. Suppose if in the question it is given that this is the wave function particle in a box, then you have to put the value of energy from the in case of particle in a box, which is equal to n square pi square a square divided by twice m square. Okay. This numerical I have given only to understand a particular topic. Once after finishing this chapter number 3 of Zettili book, I will go through each set of numerical, different type of numerical, and if you solve it, then you can understand easily and you can qualify the exam also, because this type of question often asked in exam. Consider a system. Another problem is consider a system of x0. This is x0 equal to rho t by t phi 1. Next 2 by t phi 2. Next rho 2 by 3 phi. First of all, then also given as psi n m, okay, delta m n, and h phi n is equal to n in phi n. Okay, this is the energy eigenvalue. Okay, that means energy of this equation tells that energy of the system. For example, particle in a box. If the problem is defined as this is the wave function particle in a box, then we have to use this En equal to how much? N square pi square h square divided by twice m a square. In case of particle in a box, but here it is given the energy. This is the energy eigenvalue equation. So energy of the system is n E naught. This equation means okay. Then first question, whether the wave function is normalized. So how can you identify whether the wave function is normalized or not? Just square coefficient and add up. If you have to ensure sum of a n square equal to, if it is equal to 1, then it is normalized. So you see, it will equal to 3 by 9, 4 by 9, 2 by 9, 7 to 9 equal to 1. This wave function is normalized. If this wave function is normalized, then if somebody asks you what is the probability of finding wave function at state 2, just square of coefficient. Okay, square of the coefficient. And similarly, if this state is a square of coefficient, nothing to do anything. You just square the coefficient of that particular state. Okay. This is what. Second question is that. Second question, what is the wave function at time t? Time t wave function if in case of a harmonic oscillator. Find xt if it represent harmonic oscillator, one-dimensional harmonic oscillator particle. Then how can you define? This is just psi x t is equal to t by 2 or t by 3 psi 1 e to the power minus I e1 t h cos. Okay, first step that is why it is written as. Second stage 2 by 3 pi 2 e to the power minus I e2 t. Okay, by h cos. Third stage root 2 by 3 pi 3 e to the power minus I e3 e h cos. Okay, now what is the value of energy? Now you have to put this value E1 step, E2 step, E3 step. Okay, what is the value of En? En equal to n plus half h cross omega. So here, remember here E1 means energy of the ground state. You do not put the value n equal to 1, n equals n start from 0. So it will be E1 equal to E naught equal to half h cross. And E2 equal to E1, that means n plus 1 plus half h cos omega equal to 3 by 2 h cos omega. So E3 equal to E2 5 by 2 h cos omega. Now this 3 value you put it here. That is the answer. This question often carry 3 marks question. This is a very easy question. Okay. In the last time in GATE exam, this question comes. The wave function in the spin wave function 0.8, 0.6 downstairs. Okay. This is the wave function is given. This is the spin wave function of a particular system, and this is represented by Riemann. And what is the probability of finding the electron in spin downstairs? It is just simple, similar to A1 phi 1 plus A2 phi 2. Okay. In some time this equation will give. This equation is often represent 1 0. This 1 0 plus 0.601. It is sometimes it is represent like this, and sometimes it is represent 0.8 half minus half. Okay, plus 0.6 half minus half minus. It is represent. All the equations are same. Okay, what is the probability in the down state? This is what? This is square. This is square. Now it is normalized. So probability is the square of this 0.6 square 0.36%. 36% probability in down state, and this 64% probability in upside. This is how we have to answer. Okay. And this is the basic understanding and postulate of quantum mechanics. Rest of the things I will discuss in the later. So you just try to understand the state of quantum mechanical system and how to calculate probability from discrete system. Continuous system I will give you later in the next class. Okay. And mean energy I have given in calculation. Okay. So you can similarly in statistical physics also we often calculate probability. See, I have one example I want to give you. In statistical physics, suppose a particle has two energies. A particle has two energies. Suppose zero energy, and this is suppose an electron. This is two energy level. Okay, this energy level is written as E2 phi 1 and phi 1. Okay, this is the energy, possible energy level of electron. Okay, this total wave function is represented as A1 phi 1 plus A2 phi 2. Then we can probability P1 state, A1 state is equal to A1 square plus A2 square. And similarly P2, A2 we can calculate A2 square, A1 square plus A2 square. Okay, this is in quantum mechanics. That means quantum mechanics we often calculate the probability from the wave function, because wave function is the main function for which particle state and particle representation of the particle is often described in quantum mechanics. But in statistical physics, suppose if what is the formula in statistical physics, we often measure the probability from the energy level. Okay. This is a numerical value, this is also numerical value, this is known as a partition function, and partition function is number of possible microstate. Microstate means what are the possible microstate? Here it is 2. So we will represent this is non-resonant system. Okay. So probability in down state, 0 state, it will be e to the power minus 0, e to the power 0 plus e to the power minus beta e. Okay, in statistics, 1 plus e to the power minus beta e. In statistics, and probability in downs upside in upper energy level, it will be denominator will be remain same, numerator will be e to the beta. Now if we add this P0, now if we add this P0 plus PE, it will give a 1. Similarly here also PA1 plus PA2, if you add this, it will be 1. So both conditions satisfy the probability condition, that is probability should be 1, maximum probability. So in statistical view, this is a quantum mechanical view, do not confuse. Okay. Why I am giving, then you can easily understand. You merge quantum mechanics as well as physics. If you want, you can add, you can join the condensed matter physics and read at a time. Then you can easily understand. All subjects of physics are interrelated. Okay. Thank you. So I request all of you to see the video starting from starting point to ending point. Then you can easily understand quantum mechanics. Once you easily understand, or you try to go slowly in initial stage. Once you understand, you see my video. Accordingly, you try to understand and you follow the book. After that, whatever numerical given in a question in the book, you just practice that book and try to understand and try to extract the information from the book. And then any question, any type of question in an exam, you can easily understand. Okay? Thank you.